Say another interesting example could be that what would be, for example, the limit when I say that x goes to say infinity and I have log of x by say x minus 1, same function. Okay. Now if you see, how do you substitute, how do you, for example, compute the limits? I mean, if you remember, you say that, okay, the first in the first attempt you substitute the limit into the function and see that whether you, what you get actually, whether you get a meaningful expression or not. So if I substitute x equal to 1 in log, so I'm going to get log 1, and we know that log of 1 is 0. Okay. And if you substitute x equal to minus 1 here, so you're going to get 0 again. So the question is, what is the meaning of 0 by 0? You have 0 things and you want to divide them in 0 things actually. The answer is, you can't say 1. So it's not like 2 by 2 or 3 by 3 or 4 by 4. So 0 by 0 is a weird kind of a situation actually. So you call this form, for example, 0 by 0, which does not make sense, as an indeterminate form actually. In other words, this is a form for which I can't say now that what does it mean. Okay, I need to do more investigation actually. Okay. If you think about this actually, so you're going to have a sine 0. So sine 0 is 0 divided by 0. So this is also a 0 by 0 type situation actually, where the numerator is becoming 0, denominator is becoming 0. So what would be the meaning of dividing 0 by 0? You can't determine it actually. So you can't determine it. Maybe 0 by 0. Especially, for example, in this, I mean, if you remember this limit, this is equal to 1. But does it mean that 0 by 0 is equal to 1? Right? Equal to 1 actually. But in some situations you will see that if you have 0 by 0, okay, the limit would be equal to 2. But does it mean that 0 by 0 equal to 2 actually? So it doesn't make sense. Okay, so 0 by 0 is a kind of an indeterminate form. You can't say anything about it actually. That, whether it would be 1 or it would be 2 or it would be what actually. Okay. You can have any number equal to 0 by 0. So if I have 0 equal to 0 by 3, okay, I can be a bit naughty. So 0 is equal to 0 by 3. So if I divide this 0 on other sides, you're going to get 0 by 0 equal to 3. Or you can have, I can write a 4 here, then the 0 by 0, would be equal to 4. So you're going to say, this is nonsense actually. It doesn't make sense. So whenever you are computing a limit and it turns out that by substituting the limit in the numerator you are getting 0 and in the denominator you are getting 0, you're going to say, I can't compute this limit in its current form. So what should be done? How about this one actually? So take the limit x goes to infinity. So the log of infinity would be infinity. And 0 minus infinity minus 1 is again going to be infinity. So you're going to say this is like an infinity by infinity form. So this is another indeterminate form actually. So 0 by 0 is an indeterminate form. Infinity by infinity is an infinity. What is the meaning of dividing one infinity by another infinity? And you might have heard that fact actually, that okay, some infinities are bigger than other infinities. So who knows which infinity is this and which infinity is this? How can you define or make sense of dividing 1 infinity by infinity. You can't say that infinity by infinity equal to 1. So indeterminate form will start with say 0 by 0 and infinity by infinity. The question is, if you are in such a mess actually and you want to compute the limit, the answer is how to do it, and the answer is you can do it through what you call very easily through L'Hopital rule. Now what is L'Hopital rule? Okay. It's written as hospital, but you don't read it as hospital. Okay, the H is silent actually, so you read it as L'Hopital's rule. Okay, L'Hopital's rule, and you'll see that what magic this L'Hopital rule can do actually. Okay, so what does L'Hopital rule says? Says that suppose you have two functions f of x and g of x, and suppose g is not 0. Okay, suppose you have function f of x and g of x, and they are differentiable. In other words, you can derivate them. Okay, or differentiable. So these are two differentiable functions whose derivative you can calculate. Okay, and in addition, you say that g prime of a is the point where we will compute our limit is not equal to 0. Okay, so 0 is not allowed in denominator. But the trouble with the f and g is that when I am computing say limit x goes to a f of x, I am getting 0, and when I am computing limit x goes to a g of x, I am getting 0. Or the other situation could be that you are computing x goes to a f of x, and it turns out that you get what do you call infinity. That infinity could be positive and negative. So you get plus infinity or minus infinity, say. And you compute, for example, a g of x, okay, and you are also getting plus or minus infinity. Now here is an interesting thing. Say I want to compute what if the limit x goes to a f of x by g of x. So imagine you are in this situation where limit x goes to a f of x is 0 and limit x goes to a g of x is 0. The numerator is becoming 0 and denominator is becoming 0 as well. So you're going to have a 0 by 0 situation. Then the question is how to compute this limit. The answer is you can do it in this manner. Okay, let's talk first about the other possibility. The other possibility could be that, okay, you have limit x goes to a f of x, you know, say this is plus infinity and this is also plus infinity. Then this would be infinity by infinity, or negative infinity by negative infinity, or it could be positive infinity by negative infinity, or negative infinity by positive infinity. So you're going to have a lot of crazy things. So if you have a 0 by 0 form in a given limit, or an infinity by infinity form in a given limit, then you can compute this limit by doing what? Calculate the derivative of the denominator, calculate the derivative of the numerator, and compute the limit. The both limits would be equal. This is interesting. If you want to compute this limit, and it turns out this has a 0 by 0 or infinity by infinity form, then this limit is also equal to the limit f prime of x by g prime of x. In other words, derivate them and then compute the limit. Okay? Then compute the limit. and then whatever this limit is, this is same as this limit. So it's like a Santa Maria miracle actually, huh? So let's say you have limit x goes to 1 log x over x minus 1. I want to compute this limit. But since I am computing this limit, my log 1 is giving me 0 and x minus 1 is also giving me 0. So it's a 0 by 0 form. It's a 0 by 0 form actually. So L'Hopital rule says that this limit is the same as that you differentiate the numerator. So what would be the derivative of log x? So it's going to be 1 over x divided by, what would be the derivative of x minus 1? So it's going to be 1 minus 0. So 1 minus 0. So if you simplify this, you're going to get limit x goes to 1 over x, because dividing by 1 is not going to change anything. And what would be this limit? This would be limit is going to be 1 over 1, so equal to 1. So hence this limit, okay, which has this indeterminate form 0 to 0 is equal to 1. Okay, is equal. How about the other limit? Say sin x goes to sin x upon x. Sin x upon x. So limit x goes to what do you call 0 sin x upon x. So this is also a 0 by 0 form. 0 by, what do you call 0 form? So it's a 0 by 0 form. And you want to compute this limit. So how are you going to compute this limit? If you can't, by directly substituting 0, you are getting 0 by 0. So you can apply L'Hopital rule. By L'Hopital rule, this limit is equal to what limit? Limit x goes to 0. Derivative numerator, so it's going to be cos x, derivative denominator is going to be 1. And if you substitute the limit, so you're going to get what do you call cos 0 by 1, so this is equal to 1 actually. Okay? So you get indeterminate form. So the sin x by x is 1. Okay? So that's how you can do the interesting thing actually. Let's do, for example, one example of infinity by infinity. Okay. So infinity by infinity. So there are different indeterminate forms, so you have to use the trick. So this is, so if you have 0 by 0 form, you can do this. So let's, for example, do limit x goes to 0. Okay. The limit x goes to infinity. E to the x over x square actually. Now I know that limit x goes to infinity if I will compute this e to the x, so this would be equal to infinity. And if I compute, say, limit x goes to infinity x square, okay, so this would be again infinity as well. So this is like an infinity by infinity form. Okay. So how to compute it? So by L'Hopital rule, okay, L'Hopital rule, by rule, how you can compute this? Limit x goes to infinity, so you get e to the x, derivative of e to the x is e to the x, and derivative of x square is 2x actually. Now see that can we now make sense of it? Now think about it. Limit. Now if I substitute, for example, I'll take the limit x goes to infinity, e to the x is going to be again infinity, and limit x goes to infinity 2x is going to be again infinity actually. So the trouble is, applying the rule didn't help. Still you got infinity by infinity form. If this is the situation, applying the L'Hopital rule for once did not solve the problem, then what you can do, apply it again. So nothing is stopping you actually. So if you can apply this again, what are you going to get? You're going to get limit x goes to infinity, e to the derivative of e to the x is again going to be e to the x, and the derivative of denominator is going to be equal to 2. And now this limit will become what? So limit x goes to infinity, e to the x infinity is really infinity divided by 2. So if you have infinity and you put it into the two pieces, you're still gonna get infinity. Okay. You're still gonna get what do you call infinity. By the way, you need to keep this in your head, that if you have infinity divided by any number, any fixed number, 1, 2, 3, 1.5, whatever, this is infinity. And if you have any number divided by infinity, okay, we're going to call it 0. Okay, so this is, I'm writing it in inverted commas actually. Okay, so this is, you can't really divide by infinity and infinity actually. Okay, so if the infinity is in denominator and the numerator is a number, that's 0. And infinity by a, infinity divided by some number is going to be still infinity. Okay, you can have a sense actually that why a divided by infinity is going to be 0. If I say that, okay, I have one, piece of cake, and I want to divide it into what do you call lots and lots and lots and lots of pieces actually. Then every piece, the size of the every piece is almost going to be 0 actually. Okay, is almost going to be 0. So if you have a number and you want to divide it into many pieces, so you're going to say, okay, each one of the piece has a size almost 0. So therefore you always say that, okay, something divided by infinity is 0 actually. Okay, I can write a more, what do you call a precise term, that if you have limit x goes to infinity, x divided by say some constant, so a is a fixed constant, this must be infinity. And if I have say limit x goes to infinity, some constant divided by x, so this would be 0 actually. So if the infinity is in numerator, the fraction is infinity, okay, the fraction, and if your denominator is growing more and more and more, okay, so it's like becoming infinity or going towards infinity, then the fraction would go to 0. But you can't have infinity over infinity both in the numerator and denominator. Then you have to apply what you call the L'Hopital rule. Okay. So for example, here's one interesting question. So I have limit x goes to infinity, log x by cube root of x. Okay, so x power 1 upon 3. Okay. So what is limit x goes to infinity log x? So it's infinity. What would be the limit x goes to infinity x power 1 upon 3, so it's like substituting in inverted commas, infinity in x power 1 upon 3, so it's going to be infinity again. So this is like an infinity by infinity form. So what to do next? Apply the, what do you call, L'Hopital rule. So let's do it. So limit x goes to infinity, this is equal to the derivative of the log, which is 1 over x, divided by the derivative of x power 1 over 3, so it's going to be 1 over 3 x power 1 over 3 minus 1, so it's going to be minus 2 over 3 actually. Okay, and you can simplify this a little bit more. Limit x goes to infinity, so you have 1 over x divided by this x power minus 2 upon 3, okay, and if you limit x goes to infinity, so it's going to be x power minus 2 upon 3x. I can put these powers in a single x, so if I can do what? So I can do limit x goes to 3, 1 upon 3x power 1 plus 2 upon 3. Okay, this is something that you're going to get. And now, if you simplify this even more, so it's going to be limit x goes to infinity 1 over 3x power, so you have 3 plus 1, so 5 upon 3, and now substitute the limit. So my numerator is a constant and denominator is getting bigger and bigger and bigger, so x is getting bigger. So when you say that x goes to infinity, it means that it's getting bigger and bigger and bigger. And when your numerator is a constant and denominator is getting bigger and bigger and bigger, you should get a 0. So this should be equal to 0. Okay? This should be equal to 0. So the limit is 0. So as I said, that if the L'Hopital rule does not work once, you can use the L'Hopital rule multiple times actually. For example, in one example, we applied L'Hopital rule once, it didn't give an answer, still you are getting infinity by infinity. Then again apply L'Hopital rule and you got some answer. But imagine again you got infinity by infinity. So what you're going to get? Again apply the L'Hopital rule. So you keep on applying the L'Hopital rule until and unless you get something concrete. Now let's move towards some more indeterminate form. So imagine I have 0 by infinity. So I have something that is multiplied by 0 by infinity. Okay? So if you have, so this is also indeterminate form. What do you mean by 0 multiplying by infinity? Okay? So you may interpret it, okay, you want to multiply the 0 infinite times. What do you mean by multiplying the 0 infinite times? So you're going to call this is indeterminate form. So we had 0 by 0 as indeterminate form, infinity by infinity as indeterminate form. So this is the third indeterminate form. This is third indeterminate form. Okay? How to deal with it? Okay, so in order to deal with this third kind of indeterminate form, what you need to do, try to convert it into, what do you call, we will try to convert this into either 0 by 0 form or infinity by infinity form, okay, and then apply the L'Hopital rule. Okay, so this is what that you have to do. Okay, convert it to 0 by 0 form or infinity by infinity form, and then do it. So for example, I have a function f. So how to do it? So imagine you have a function limit x goes to a, and then this gives you 0, and I have x goes to a, g of x is giving me infinity, and I want to compute what you call limit x goes to a f of x multiplied by g of x actually. F of x multiplied by g of x. Now this would be 0 times infinity, so it would be indeterminate form. The question is, how can I convert it into 0 by 0 or infinity by infinity form? The answer is, you can play a trick. So do the limit x goes to 0 a, okay, and write this as f of x divided by 1 upon g of x. So I haven't changed anything. So f of x divided by 1 upon g of x is really equal to f of x times g of x. So nothing has changed. But now think about what will happen. So if as x goes to a, f of x would be still 0, and limit x goes to a, 1 over g of x. G of x is becoming infinity. So this is like 1 over infinity. Okay? So it's going to be 0 actually. So numerator is 0, and limit x goes to a, g of x, denominator is also 0. So now you wrote the 0 by infinity form, you converted the 0 by infinity form into 0 by 0 form. So what will happen now? Apply the L'Hopital rule on it. You know, derivate numerator, derivate denominator, and compute the limit. You will see that you will be able to get the limit. For example, here is an example. Here is an example. So let's take the limit x goes to infinity, okay, x log x. Okay, x log x. Now what are you going to do? You're going to say, this is like, okay, so what to do? So if I take limit x goes to infinity, so this would be infinity. Okay, so this is not 0, but this is 0 actually. 0 plus. Not infinity, but 0. So 0 plus means from the right of the 0 actually. So if you substitute 0 here, so it's going to be 0. And what would be the log of 0? So it's going to be infinity, negative infinity. So this is like a 0 by infinity form. 0 by infinity form. Okay.